give a warm welcome to Emily Katz from Michigan State, who we owe really at least two thanks. One of which is favoring us with the presence of a real historian against those of us who have more contemporary metaphysical talents and just kind of dabble in the history. And second of all, for being so willing to do so early in the morning to her time, and not only that for your own talk, but coming earlier to listen to some other talks. So thank you so much. We really appreciate your presence, and take it away.
Thanks so much for inviting me. I was really sorry to not be able to get up quite early enough to take in the earlier talks, but I'm really happy that they're being recorded. So I'm gonna do the first half of the conference later by watching the recordings. So yeah, my plan is to just talk through my interpretation of Aristotle's view about numbers, what they are, how they're in the world, and I'm going to refer to the key text so you can see what grounds my interpretation. Since I'm a genuine historian, I'm going to read my paper, but that's what we do. But I did make you a slideshow because I think that's what you do. So hopefully I'll be able to manage reading and moving through the slides. We'll see. Okay, so although I'm a historian, everything I'm going to say is highly opinionated. Nevertheless, I think I have good reasons for the opinions, but I'll try to show you what they are. So here's an overview of what I'm going to do. So I'll start by giving a sketch of Aristotle's basic view, namely that number is something in the external world. I'll then take a step back and give an overview of Aristotle's philosophy of the sciences so that I can show how his philosophy of mathematics fits in. And then we'll get a little bit into the weeds when I discuss Aristotle's view that there are really two kinds of number, a quantitative sort and a relational sort. And I'll then consider which of these are the objects of arithmetic. And I'll finish by saying something about how number is perceivable. And if there's time, I might follow up on Ryan's suggestion that Aristotle allows for non-material quantities, something that came up in Ryan's talk, but I'm not sure if there'll be time to do that. I'm going to try my best to pitch this to both Aristotle scholars and those who are less directly engaged with his writing. So we'll see how that goes. Okay. Oh, first problem already. How do I move through the slides? There we go. Okay, so the first thing to know is that the Greek word we translate number, arithmos, covers just the natural numbers 2 or greater. And that's not true just for Aristotle, but for the Greeks generally. And arithmos is a kind of plurality, and what is one is contrary to what is plural. So 2 is the first plurality, and that means 2 is the first arithmos. I'm just going to call this number, but it's important to keep in mind which numbers I mean. So then, what's the status of number for Aristotle? His basic view, as I interpret it, is this. Number is a certain kind of quantity, and quantity is something that exists in the external world. So it's a feature of physical reality. Numerical quantity, number, is a certain kind of plurality. It's one that's divisible into indivisibles that measure it. Another way to put this is to say that a number is a plurality that consists of indivisible parts into which it's equally divided, namely units. And a plurality that consists of units is a specific number, say 17. So for example, a herd of horses is a plurality that's divisible into indivisibles that measure it, that is, into which it's equally divided, in this case, horses. Horses, of course, are divisible, but they're indivisible insofar as they're horses. So you can divide a horse up into many body parts, but you can't divide a horse into many horses. And the herd divides equally into horses. So horse then is a unit relative to the herd. So let's say that this particular herd has the quantity 17 horses. 17 horses is the number of the herd, and so is a feature of something in the external world. Now, there might be already some need for clarification here. Does the plurality have a number, or is it a number? And in fact, Aristotle is committed to both. The herd has the number 17 horses, and the herd also is the number 17 horses. How can he consistently be so committed? Well, it's because he thinks a plurality is a number just insofar as it has a number. And to explain that, I should first say how, for Aristotle, the objects of every science, including arithmetic, are in the world and how we grasp them. Okay, here we go. So consider that each sensible thing, each perceivable material thing, such as a horse, a human being, or a tree, has innumerable properties. For example, a human being has a certain age, height, weight, hair color, preferences, aversions, skills, hobbies, moral qualities, and so on. Aristotle argues in Metaphysics Book 6, Chapter 2, that no science is concerned with all of a thing's properties. He explains in Metaphysics Book 13, Chapter 3, that what each science does is to study a certain sort of thing just insofar as it's a thing of that sort, and to consider just those properties it has in virtue of being a thing of that sort. And so what each science does is ignores or sets aside the many properties that are incidental to an entity's being a thing of that sort. For example, medicine is the science of human health, and so it studies a human being, we'll call him Martin, just insofar as he's something capable of health, or as we would say, qua patient. So Martin's preference for the color blue, his aversion to jazz, his being an avid gardener, his having the first 12 digits of pi memorized, his being generous but not terribly courageous, and any number of other such qualities are all incidental to health, and so they're not included in the doctor's object, in Martin qua patient. And so the doctor, when practicing medicine, sets aside all such properties. So this subtraction of features that are incidental to the object of a given science is what Aristotle calls aphiresis, which in Greek is just the opposite of the word for addition, prosthesis. Aphiresis often gets translated abstraction, but subtraction is a more literal and I think less misleading translation. So the idea is that when the doctor considers Martin qua patient, she engages in aphiresis. And this just means that she's still studying Martin, but she's setting aside or ignoring as irrelevant any features he has that are incidental to his health. And so she's isolating the object of medicine, the patient. And this object, which is isolated by aphiresis, is still the original subject, Martin in this case, but just insofar as he has the capacity for health. And this entity, the health-capable thing, is what's sometimes in the literature called a kooky object. So let me just say a few quick things about kooky objects so that what I'll go on to say about number will be a little bit clearer. And I'll keep using the example of Martin. So for Aristotle, the kooky object, the health-capable thing, inheres in or is predicated of Martin, the subject. And even though the health-capable thing is Martin, qua his capacity for health, still the health-capable thing and Martin are also in a way distinct. And Aristotle shows this in a number of ways, but I think the clearest is this. Even if Martin, of course, Martin's not Aristotle's example, but he gives a parallel example. So even if Martin loses his capacity to be healthy, say if he develops an incurable illness, he persists, while the health-capable thing does not persist. So these two entities are distinct. On my view of Aristotle's philosophy of science, every science's objects are kooky objects. For example, while medicine, anthropology, and painting all sometimes study human beings, they study different kooky objects that inhere in human beings. So medicine studies the health-capable thing, anthropology studies the member of a human culture, and painting studies the colored and shaped thing. So my view is that for Aristotle, the same is true of the mathematical sciences. He explains in Metaphysics, Book 13, Chapter 3, that geometry studies a human being qua solid, while arithmetic studies a human being qua indivisible unit. So geometry studies Martin just insofar as he's a solid, and so divisible in length, breadth, and depth, Well, arithmetic studies him just insofar as he's one indivisible human being, and so a unit for counting human beings. And to put it in terms of kooky objects, geometry studies one sort of kooky object that inheres in Martin, namely the solid thing, and arithmetic studies a different kooky object that also inheres in Martin, namely the indivisible human unit. When Aristotle gives his clear statement of his philosophy of mathematics, which is in Metaphysics, Book 13, Chapter 3, he really emphasizes that the mathematician has her objects in the same way as all other sciences studying things in the external world, basically by considering x qua f, and so separately from anything incidental to x's being f. So natural science studies sensible objects qua changeable and treats them separately from anything incidental to their being changeable. Gynecology studies animals qua female and treats them separately from anything incidental to their being female. Geometry studies sensible magnitudes qua solids, qua planes, or qua lines, and separately from anything incidental to their being such. And arithmetic studies sensible objects qua units and separately from anything incidental to their being such. On my interpretation, to consider x qua f is to engage in aphiresis, that is to subtract or set aside all features of x but f, and those features that hold of x just because it's f. But Aristotle's also well aware that there's something special about mathematics and mathematical objects. This is because, as he notes in Metaphysics, Book 11, Chapter 3, the geometer considers sensible magnitudes just qua quantitative and continuous. And this means that mathematical aphiresis subtracts not just some, but all sensible features of the objects it considers. For his part, the arithmetician considers sensible pluralities qua quantitative and discrete. And again, all sensible features of these pluralities are incidental to arithmetic. So while mathematical objects, like the objects of other sciences, inhere in the sensible world, just as zoological and medical objects do, they are what they are completely independently of the sensible matter in which they inhere. A circle is a circle, whether it's made of bronze or wood or any other sensible matter. And the same is true of number. 17 is 17, whether the units are horses or dice. Since mathematics alone subtracts all sensible features and considers its objects separately from sensible matter, Aristotle sometimes refers to mathematical objects as objects from aphiresis, and this sometimes gets translated abstract objects. I take it this moniker means not that only mathematical objects are isolated by aphiresis, but rather that they're isolated by the most extreme aphiresis, the subtraction of sensible matter itself, and so the subtraction of all sensible features. So with that picture of Aristotle's philosophy of science on the table, I think we're in a good position now to return to and flesh out his views about the status of number. Okay. So far, I've argued that number for Aristotle is a kind of quantity, and that as such, it's something in the sensible world. It's a pluralities consisting of indivisibles into which it's equally divided. So consider a plurality like a tree's foliage. Just as greenness and being an oxygen producer belong to the foliage, so does its number of leaves, let's say 1,000 leaves. Quantitative numbers like 17 horses or 1,000 leaves are what Aristotle calls countable numbers. Countable numbers are definite quantities of a specific kind of unit. And it's important that the unit be specified because each plurality has as many numbers as it has kinds of units. That is, each plurality has as many numbers as it has kinds of indivisibles into which it's equally divided. So a tree's foliage might have the quantitative countable numbers 1,000 leaves, 8,000 lobes, and 10,000 veins, along with many others. And recall that we can also say that the plurality qua these numbers just is these numbers. The foliage is a 1,000 of leaves, an 8,000 of lobes, and a 10,000 of veins. But now we have a bit of a complication because Aristotle also claims that number is always a number of something, of things of a certain kind. And if number is always of something else, then it's a relative. But a quantitative number isn't a relative. 1,000 leaves is not 1,000 leaves of something else. So Aristotle has two kinds of number. And actually, Eduardo brought this up in the Q&A for Lorenzo's session. As we've just seen, Aristotle recognizes quantitative countable number, which is a plurality qua it's being measured by a specific unit. The foliage is a 1,000 of leaves. But he also recognizes another kind of number, which is a plurality just qua a property it has relative to what measures it. For example, the foliage has the property 1,000 relative to the measure leaf. That is, 1,000 is a relational property of the plurality, and the plurality qua this property is a number, 1,000. Now, there's lots of textual evidence that Aristotle considers number a relative, and more specifically, the measurable relative to a measure. I think he's clearest about this in Metaphysics, Book 10, Chapter 6. I think I made a slide for this. Yes. And this is what he writes. Plurality is like a genus of number. For number is plurality measured by one, and in a way, one and number are opposed to each other, not as contraries, but as we said that some of the relatives are. They're opposed in that one is measure and the other is measurable. Now, since Aristotle elsewhere defines number as measurable plurality, he's here identifying number with the measurable and the one with the measure. So number is one of the relata in the measurable measure relation. But are these really two different kinds of number? What's going on here? Basically, by having two kinds or senses of number, Aristotle seems to want to explain how it is that two different pluralities, say a herd of horses or a group of people, have the very same number and so are equal, even if they have different units, horse units and people units. But let me explain that in just a little more detail. So we've seen that for Aristotle, the same plurality can have different numbers. The foliage can be 1,000 leaves and 8,000 lobes. But he also accepts the reverse, that is, that different pluralities can have the same number. In Physics, Book 4, Chapter 11, he claims that a number belongs to what it numbers, and he says belongs also elsewhere. So he says 10 is the number of these horses, but also the number of other things. In Chapter 12, he explains that, quote, the number of 100 horses and 100 people is the same. And in Chapter 14, he writes, if there were dogs and horses and 7 of each, it would be the same number. To be clear, Aristotle maintains only that the number of each plurality is the same. He claims that the plurality itself is different in each case. In the Book 4, Chapter 12 passage that I just mentioned, he continues, quote, but the things numbered are different, the horses or the people. And in Chapter 14, he writes, quote, it is rightly said, too, that the number of the sheep and of the dogs is the same number if the two numbers are equal, but not the same decad or the same 10, end quote. He explains that it's not the same 10 because, quote, the things of which it is asserted differ. One group are dogs and the other horses. Since Aristotle insists that the number of the dogs and horses is the same, but that it's not the same 10, he seems to be working with two kinds of number. And these are the things numbered, for example, 10 horses, and the number of those things, that is 10. The first is the quantitative countable number that we've already seen. So we can say of the plurality in the field that it's a 10 of horses, and we can say of the plurality in the kennel that it's a 10 of dogs. 10 horses and 10 dogs are different numbers or different tens because they're pluralities of different units, horse in the one case and dog in the other. Yet Aristotle argues that the number of them is the same, 10. And this is just to say that each plurality has the same property, 10, relative to a given unit, horse and dog, respectively. Aristotle calls this relational sort of number a counting number, or the number by which we count. And what I'd like us to notice is that this isn't actually something special about number. It applies even to non-numerical relatives. For example, tall is a relational attribute that my brother has relative to me, and also a relational attribute that, this tree has relative to that shrub. While the property bearers differ in each case, my brother or the tree, and while each has that property relative to a different relatum, me or the shrub, the property tall is the same in both cases. In the same way, while the bearer of the relational property 10 differs in each case, plurality of horses or plurality of dogs, and while each has the property 10 relative to a different relatum, a horse or dog, the property 10 is the same in both cases. This relational property, shared by all countable tens, is a number by which we count, or a counting number. For example, when I count up dogs, I go through the dog units one by one, each time counting off the next in the series of counting numbers 2, 3, 4, etc. So I count the countable dog number by the counting numbers. Now, at this point, I think it's reasonable to wonder how these two kinds of number are related to one another. Well, in Physics Book 4, Chapter 14, Aristotle argues that just as equilateral and scalene triangles are different kinds of triangle, but the same kind of figure, namely triangle, so 10 of horses and 10 of dogs are different kinds of 10, but the same kind of number, 10. What makes 10 of horses a different 10 from 10 of dogs is just that 10 is said of different things. But 10 of dogs is still equal to 10 of horses. They're the same kind of number, namely tens, because neither dog nor horse is a differentia of number. So prime, odd, even, and so on, those are differentia of numbers. They're ways in which one number differs from another as numbers, but not so horse or dog. So the relational counting number 10 is the kind or genus, and the quantitative countable numbers 10 of horses and 10 of dogs are, as it were, species of 10. Just as equilateral and scalene are species of triangle, so 10 of dogs and 10 of horses are species of 10. Or to put it in different terms, terms that would be utterly foreign to Aristotle, the countable number is the counting number saturated. So the counting number 10 is unsaturated. It's always a 10 of blank, and so it's a relative. By contrast, the countable number 10 of dogs is saturated. 10 of blank has been filled in with the relatum dog, and such a saturated entity is a quantity. Now, someone might worry at this point that Aristotle shouldn't recognize relational number at all because a relative isn't a plurality, and Aristotle, after all, defines number as a kind of plurality. But while relational number is a relative, namely the measured thing relative to the measure, the unit, the measured thing, a kooky object, is ultimately just the plurality qua its relational property of being measured. For example, 1000 is a plurality, the foliage, just insofar as it's measured as 1000 relative to the measured leaf. Similarly, as we've seen, a quantitative countable number like 1000 leaves is really just the plurality qua its quantitative property, 1000 leaves. So in short, the relational number 1000, like the quantitative number 1000 leaves, is ultimately just the plurality, in the former case qua a relational property, and in the latter qua a quantitative property. So now that we have the view on the table, we can address a key epistemological question. Which are the objects of arithmetic? Quantitative countable number or relational counting numbers? It turns out that each is the object of a different kind of arithmetical activity and statement. Counting up sheep is the kind of arithmetical activity that produces true statements like there are 10 sheep in the field. For Aristotle, this statement is true of the plurality in the field qua its quantitative property, 10 sheep. Since 10 sheep is a countable number, arithmetical statements that result from counting up a plurality are about countable numbers. Now consider a different arithmetical activity, comparing the numbers of two pluralities. Such activity produces true statements like the number of sheep in the field is equal to the number of dogs in the kennel. For Aristotle, what makes such a statement true is that the pluralities in the field and kennel have the same relational property, 10, relative to the units sheep and dog, respectively. In Physics, Book 4, Chapter 14, he maintains that it's rightly said that, quote, the number of sheep and of the dogs is the same number if the two numbers are equal. So arithmetical statements comparing the numbers of different pluralities are about pluralities qua their relational counting numbers. The pluralities in the field and kennel are arithmetically the same, that is, equal, when each is considered just qua their relational counting number. Finally, which numbers should we say are the objects of purely arithmetical statements like 4 plus 6 equals 10? At first glance, it seems they should be the relational counting numbers 4, 6, and 10 tout court. But for Aristotle, the 10 of a purely arithmetical statement is a 10 of something. That's a 10 of pure mathematical units. And a 10 consisting of such pure units is what Aristotle calls mathematical, arithmetical, or monadicon number. And I think it's distinctive of Aristotle's view that a number of pure units is the same kind of being as a sensible plurality like 10 of sheep, and that both are quantities. A pure unit is really just any sensible thing, just insofar as it's indivisible. And pure arithmetic considers sensible things apart from or without the sensible thing's movement, magnitude, or any other feature besides their indivisibility. So 4 plus 6 equals 10 is about quantitative countable numbers. That is, pluralities of entities from which the arithmetician has subtracted all attributes such as weight, color, being a sheep, etc., leaving only their indivisibility in some respect. So the same flock is a 10 of sheep, qua its quantitative property, 10 sheep, and a 10 of pure units, qua its quantitative property, 10 indivisibles. So I've argued that numbers for Aristotle really belong to the sensible world, and that means that he ought also to think that they are themselves perceivable, and he does. So let me finish by saying something about how number is perceivable for Aristotle and by considering how he'd address a concern this might raise. In his treatises on the soul and on sensation, Aristotle maintains that we can perceive numbers. And he claims that we perceive number especially through sight, though he also does suggest that we can perceive it through touch. On his view, we perceive number incidentally by the negation of continuity. And the idea seems to be, while the proper object of sight is color, we can see discontinuity incidentally via differences in color. And so we see that there's a number of things by seeing discontinuity. And we can then reckon the number's quantity. We can determine what the number of things is using a counting off procedure, which is not itself a perceptual procedure, though it may involve use of the senses. So basic arithmetical knowledge for Aristotle, our grasp of numbers, is grounded in perception of features of the physical world and specifically discontinuity. Now, this might raise a Fregean worry about views that make numbers perceivable properties of external objects. Frege writes, quote, one pair of boots may be the same visible and tangible phenomenon as two boots. Here we have a difference in number to which no physical difference correspond. For two and one pair are by no means the same thing. Now, Aristotle himself, of course, doesn't address any such worry, but he has the resources to do it. So here's a reply on his behalf. Given his views about perception, I take it he would reply that just because number is perceivable, that doesn't mean there has to be a distinct set of perceptual data for each number, for one pair and two boots in this case. Of course, he wouldn't say that one is a number, but we'll set that aside. The perceptual data about the same set of physical features can be used in different ways. So when we see the heat by the door, we see that there are two items by the discontinuity. Oops. Hang on. But we also see their similarities, that both alike belong to the kind boot. So Aristotle maintains that we perceive kinds or universals when we perceive particulars. When I perceive this letter alpha, I perceive an alpha. And so Aristotle claims I also perceive a universal, the kind alpha. And when I perceive Callias, I perceive a man. And so I also perceive a universal, the kind man. So when I perceive that there's a number of some things, I'm perceiving both discontinuity and sameness in kind. And that means that when we see the heap by the door, we have all the perceptual data we need to consider and count it as either two boots, two distinct items, or one pair of similar items, one kind of thing. So that's the sketch of what I take to be Aristotle's view about the reality of numbers. They're in the external world and are perceivable. The pure units of arithmetic are sensible things just insofar as they're indivisible. And the pure numbers of arithmetic are pluralities just insofar as they have a certain quantity of such units. Numbers of specific sorts of things, like 1,000 leaves, are sensible pluralities like the foliage, just insofar as it has the quantity 1,000 leaves. And 1,000 leaves and 1,000 horses have the same relational number, 1,000, which is just each of these pluralities insofar as it has the relational property of being measured as 1,000 relative to their respective units. Aristotle's philosophy of numbers is consistent with his broader realist philosophy of science in that numbers are kooky objects, certain subjects in the world just insofar as they have the properties studied by a given science. So I don't think I have time to get into non-material quantities, but thanks for listening, and I look forward to discussing these ideas.
Yeah, thanks so much to Emily. And yeah, we've got the full time for questions. So Eduardo first, but there is a queue, so try to keep them, compact.
I'll keep it short. Don't worry. So just for a comment for the sake of the listeners, I think it's very important. Something that Emily pointed out, that there is always a relative there in number. However, it is important to note that in book Delta, chapter 15 of his Metaphysics, Aristotle distinguishes multiple modes in which the relative prosti is said. And this is just the last one, which is the relation of the measurable to the measure. So there are others, like greater and less are correlative, but not this one, because in this case the measurable depends on the measure, and the measure is the cause of the measurable. I just wanted to point that out. And the other thing, also in terms of coming to know number, just to add a little bit to what Emily said, which was a fantastic presentation, is that number is among the common sensibles, so that every sense has some proper thing that it senses, a proper object that it senses, like sight senses color and so on, and yet there are some things or some objects that can be known by more than one sense, and number is one of them, together with magnitude and figure, and also, of course, motion and rest, but these are not considered by mathematics. So I just wanted to add that for the sake of the others, and thank you very much. A fantastic presentation.
Thanks, Eduardo. I think that's helpful. Yeah, there are a lot more details to the view that get us more into Aristotle's other metaphysical commitments and distinctions, but I think those two are really important ones. Yeah, thank you.
Okay, Jim.
Emily, you kept very strictly to history, but would you like to step out of that for a moment and tell us whether you think Aristotle's view of numbers is the true view of numbers?
I mean, I find that a very difficult question, because I think I've drunk the Kool-Aid a little bit on Aristotle, and I've been working real hard to separate trying to get his view right from what I think is true. I'll say a little bit about that, because, and this is something I didn't get into in the talk, but I did mention at the beginning that everything I said was highly opinionated. So there are plenty of folks who are historians who think Aristotle has a view that you would not recognize as Aristotelian, right? It's not what Neo-Aristotelian would call Neo-Aristotelian, because it's not realist. And So when I'm approaching these texts, I'm trying to balance really just what does he commit himself to in writing with the principle of charity. I don't want to give him an absurd view, but I think sometimes what happens is people try so hard to give an interpretation that they can buy into, that they can think is true, that they gloss over or ignore important things that he says in his text. So I've really tried to balance those things. As for whether I think this is true, I mean, I find it extremely attractive. I've read what some folks have done, including yourself, with Aristotelian realist philosophies of mathematics. And I've been really excited to discover, that a lot of the complaints that historians have about Aristotle and reasons why they can't think he really has the view that I think he has, are able to be addressed by people who are working in the philosophy of mathematics. So I would say for right now, I find this view very attractive, and I'll have to keep my mind open, but I would say I agree with this view.
Okay, thank you.
All right, Bo.
Yeah, thank you for that. So I want to ask you about immaterial counting. One thing that comes up in this regard, obviously in sort of logic textbooks, we're taught to count by identity, so qualitative identity, basically. Aristotle wants to count by division, but it does seem like abstract things like sets and categories and these sorts of things can't be literally physically divided. On the other hand, also, it does seem to me, if I recall, some medieval authors kind of using the term division when they talk about, you can divide, I don't know, sciences up into different categories or something. So is this kind of a metaphorical sense of division, or do you just have different modes of counting, or how does that work?
So, right. So, I mean, we have categories of being, right? And are the categories themselves material things? Well, they're ways of being, right? They're categories of being. So when you are counting, so Aristotle, I think the place where Aristotle addresses or allows for non-material accounting of non-material things or numbers of non-material things is in Metaphysics, book 14, chapter 1. And he says, well, you do have a number of things like a human, a horse, and a god. And a god is a non-material thing for Aristotle. And the unit you would use there would be living thing. So because you have the unit living thing, there's a number of a human, a horse, and a god, 3. But he also suggests just a little bit after that you even have a number of, you can count the number of categories. So I think he does allow that things that are not, form, matter, compounds in the world are nevertheless countable, and you can have a number of them. And I think, I think it has to do with the fact that number is, in a sense, a relative. So it's a property of pluralities that's independent of the nature of their members, so long as the members can be treated as qualitative and quantitatively undifferentiated indivisibles, like as units. You can count them.
Okay, that's helpful. Thank you.
But you have to find a way to specify the unit. So you have to find a common something that a man, a horse, and a god have in common.
All right, Remkes.
Forgive me if this is a bit of a naive question. I am relatively new to this. You and other speakers have been really careful to use the word plurality. What's the distance between that notion in this context and any sort of modern mathematical sense of set?
Well, I don't want to speak for others, but the word that I am translating when I use the word plurality is plethos, which means not just some discrete items, but anything that's not one. And so that seems to me to be different from set, because you can have a set that is one. Does that help?
Yeah, I think so.
There's more to it, but I'm not sure if that addresses your question or if you'd like me to say some more.
The sort of motivation behind this is there's, of course, a movement in lots of contemporary mathematical philosophy to, or set theory at least, to reduce number to set. And I was trying to figure out if this concept of number does that at all, or resists that in sort of its twofold definition that you've explained to us.
Yeah, I'm not sure. That's a good question. I don't think it's a naive question. I mean, I think, you know, when we're trying to take something from Aristotle and do something new with it, we sometimes need to let go of some of his other commitments. But doing that untangling can be a little tricky because even the words that we're using don't fully capture the Greek concept that he's working with. So a plethos, for example, is, like I was saying, not even necessarily discrete entities. So even something continuous is a plethos, and it's potentially divisible, but really plethos is contrasted with hen or one. So I think you could do something with this, but you'd be going beyond Aristotle, which I think is a great thing to do.
Thank you in any case.
All right, so we have just a minute left, so let me just try to sneak in a quick question with the chair's privilege, which is just trying to balance the question of subtraction versus abstraction for ways to translate phrases. So I, like you, feel kind of torn in both directions. On the one hand, as a historian, you want to do the kind of most literalistic thing and let the reader figure it out. So if you're making addition, write subtraction, and if it means something technical or different, well, you know, that's on the interpreter. On the other hand, as having written in defense of Aquinas' interpretations of Aristotle on a lot of occasions, I'm inclined to want to defend, you know, why he chooses the Latin terms he does, and you know, thinks they're right. So I guess in this case, I'm just wondering, even if subtraction is a little bit misleading in some sense as well, because it implies that there's something like under there that you're getting at. So for instance, with your idea of Martin the patient, it seems like it's not the case as if like we just strip stuff away until you're a patient. It's true that some of what we're going to do is ignore certain things, but we're also going to have a certain kind of intentional relationship. Like you being a patient is grounded in you and your animality and hence your healability, etc. But at the same time, it's not just that, because it also depends in a way on there being someone to view you in that way, etc.
Well, so I actually think that it is just a kind of removal that isolates something that's already there. And so you're right that somebody has to do that to isolate the object of the science. But of course, there already are no sciences without thinking minds and people, right? So but there's also no subtraction, without minds or people. So I don't know that we necessarily need to make it more than that. I think for Aristotle, it's a kind of focusing in on something and separating it off from things that are already there. And the reason this is important is that, well, and I'm not going to blame, Aquinas for any of this, don't worry. But I think people have seen the language of abstraction and thought about idealization. And I really don't think any of that's going on in Aristotle. I think we have something and we're subtracting, but the thing that we're concerned with is real and it's already there. It's a feature of the object, of the subject.
Interesting. I would want to argue with that a little bit, but I don't think we have time. So I think I have to thank you so much for your contributions and move on. So.